Dear friends, now you can see that this is the IC 7483, which is a 4-bit adder circuit. Here on this 4 pins 1, 3, 8 and 10, that is your 4-bit A3, A2, A1, A0 will be there, and 16, 4, 7 and 11, this pin is for B3, B2, B1, B0 is there. In between there is another IC 7486 is going to be connected. That will work as a control inverter. One of the input of this exclusive OR gate is connected to high, then other input is inverted, and that will work as a NOT gate. So when the other input, that is mode control, is going to be in the high state, the B0 is going to be output of the exclusive OR gate is going to be B0 bar. Output of this one exclusive OR gate is going to be B1 bar. This is going to be B2 bar, and this is going to be B3 bar. So that way you get one complement when the mode control is going to be high. Plus this is also utilized as carry in. So one's complement plus 1, that is going to be 2's complement. So when you are making the subtraction, that means from the minimum end, when you subtract some number, that is B3, B2, B1, B0, then you have to, what actually you are doing? You are adding A3, A2, A1, A0 plus B3 bar, B2 bar, B1 bar and B0 bar plus 1. That way 2's complement of B3, B2, B1, B0 you are adding, and that way you are getting the answer is going to be S3, S1, S2 and S0. That is going to be your answer will be there. So that way you can utilize the same circuit as a 4-bit binary adder also as well as subtractor also. So this way the 4-bit can be utilized. Moreover, both the ICs is 7400 series, that means TTL series, so it requires the power supply of 5 volt. So we are utilizing the positive terminal of the 5 volt supply to the IC and negative terminal to the IC, and that way only power supply is required to connect. This is the carry out of pin number 14, and this is going to be the carry in for the pin number 13. So if you want to convert from 4-bit addition to 8-bit addition, then what you have to do? Output of the C4, the CO, that is carry out, should be connected to the carry in, and both the IC is going to be utilized. Then you can consider A7, A6, A5, A4, A3, A2, A1, A0, that is 8-bit number, and similarly B7, B6, B5, B4 and B3, B2, B1, B0, that is also again 8-bit number. These two 8-bit numbers will be added as well as subtracted the same way. This number can be made 1 or 0 using this switch. You can see that A3 is going to be 1, then it is going to be light. It is going to be 0, then no lights, and it is directly connected to this pin number 1. Similarly, that means whatever data you want to maintain, A3, A2, A1, A0, that you can adjust using this one. Suppose you want to adjust that A3, A2, A1, A0 is going to be 1, 1, 0, 1. Then A3 is going to be 1, A2 is going to be 1, A1 is going to be 0 and A0 is going to be 1. So 1, 0, 1, 1, 0, 1, this data is going to be adjusted. If I want to add in this one, this is your number 13, plus you want to add 1, that means this is going to be 0, this is going to be 0, this is going to be 0 and this is going to be 1. So 0, 0, 0, 1 you are going to add. So 13 plus 1 is going to be 14. Control signal, this add signal is going to be an upside. That means carry in is going to be 0 and output is going to be 14. You can say that 1, 1, 1, 0. So this way you get the addition of this number. Suppose you want to subtract from the same number 1. From 13 minus 1, it should be 12. Then you are getting this 12. 1, 1, 0, 0. So this way you are getting subtraction also. So from the same number A3, A2, A1, A0, I have added also 1, I have subtracted also 1. This way you can take a various example, various different combination of the 1, 0, and from that 4-bit number you can add it also and subtract it also. 5 to 6 example you have to take for addition as well as for the subtraction. The same thing you can extend for the 8-bit addition and subtraction also. Only things carry out should be connected to carry into the next one. And both the IC you have to combine and you have to understand that it will work for addition as well as subtraction. Thank you very much, friends. This is 4-bit binary full adder circuit, and this way your 6th practical I have completed.